Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on Z-scores, comparing values on different scales. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint presentation in making this set of videos. For this set, I will discuss what a Z-score is and how to calculate a Z-score and comparing values on different scales. For topic 1, I will explore Z-scores as the number of standard deviations from the mean, the Z-values. I will do this using graphs and formulas to illustrate the concept. For topic 2, I will illustrate the use of the formula to find a Z-score, then to compare the values using their Z-scores. This will take more than one video, so this will be a multiple part series. Topic number 1, the number of standard deviations from the mean, their Z-values. Our example has a mean of 60 and a standard deviation of 5. I will use the number line to demonstrate some ideas about standard deviation and to help us with our calculation. The mean I will place in the center of the graph because the mean is the center of our data. Yes, the mean is a measure of center and is a little bit more complicated than that statement. But for our purposes, we will just go with that statement and place the mean as the center of our data. The standard deviation is given as 5. This is a way for us to measure, or this is a measure of how our data is spread out, the spread of our data. So I will mark the graph in jumps of 5 for the standard deviation. First, one jump of 5. 60 plus 5 will give us 65. Then a second jump. That second jump means we'll jump 5 more units. 65 plus 5 will give us 70. 2 jumps of 5 gives us the 70. 60, 1, 2, 3 jumps gives us a total of 60 plus 15, which is 75, or 70 plus one more jump of 5 gives us 75. We can also count 3 jumps below the mean as well. One jump below the mean would be 60 minus 5 would be 55. A second jump would be 5 less than that, or 50, and 5 less than that, or 45. We now have a very useful number line to describe our data set. Every X value has a corresponding Z value. The Z value tells us the number of standard deviations or standard deviation jumps from the mean. And let me repeat this. Every X value has a corresponding Z value. And the Z value tells us the number of standard deviation jumps from the mean. Both of these concepts are the key to a Z-score. Back to our graph, these are the X value, and every one of these X values has a corresponding Z value. One jump forward moves us to an X value of 65. This means that the X value of 65 moved one jump forward. And since it moved one jump forward, that's a positive 1 jump, so its z-score is a positive 1. Positive 1 standard deviation jump from the mean. So its corresponding z-score is a positive 1. 1, 2 jumps from the mean gets us to 70. If it's 2 positive jumps to get to the value of 70, that means 70's corresponding z-value is positive 2. 2 positive standard deviation jumps from the mean gives us a z-score of positive 2 corresponding to the x value of 70. 2 positive standard deviation jumps from the mean of 60 gets us to 70 and a z-score of positive 2. Next, let's look as this pattern continues as we look at 75. 1, 2, 3 jumps brings us to the x value of 75, corresponding to a positive 3 z-score, positive 3 standard deviation jumps from the mean of 60. The pattern holds for the mean as it is 0 jumps from the mean, and therefore the x value of 60 corresponds to a z-score of 0. 0 standard deviations from the mean. What happens when we look to the numbers to the left of 60? 1 standard deviation jump of 5 being the standard deviation to the left, moving again to the left, moves us down 5 to the x value of 55. The x value of 55 corresponds to a negative z-score, a z-score of -1, because it is 1 z-score to the left. 1 standard deviation jump to the left, or -1 standard deviation jumps from the mean. 1, 2 standard deviation jumps to the left, or negative jumps. This will move us to the x value of 50, which corresponds to z equals -2, -2 standard deviation jumps from the mean. To get to 45, we will take 3 standard deviation jumps from the mean of 60, 1, 2, 3, and arriving at the x value of 45 shows us that the corresponding z-score is -3, or -3 standard deviation jumps from the mean of 60. To sum up what we have discovered so far, we have a number line with x values with a mean of 60 and a standard deviation of 5 as illustrated here. The z-value is the number of standard deviation jumps from the mean. This can be used to create the corresponding z-score as shown below our original number line. Notice how it is lined up with 0 below the 60, 1 below the 65, -1 below the 55, 2 below the 70, -2 below the 50, 3 below the 75, -3 below the 45, and we also have a reminder that x equals 45 is the x value and its corresponding z value is -3. And the table completes that reminder of what we have. And this is reinforced both in the table and in the number line. Now, as we look at this, we want to think about one other concept. The numbers 45, 50, 55, 60, 65, 70, and 75 are not the only numbers that could be in our data. We could have numbers that fall in between this. With that in mind, let's look at the formula. To calculate z-scores or z-values, we do not want to have to use jumps every time. We can use a formula. The formula is z equals x minus the mean over the standard deviation. X minus mu divided by sigma. X is our data, mu is our mean, and sigma is our standard deviation. You can use this formula to find the number of standard deviation jumps from the mean. If z is positive, then the data value is to the right of the mean. If z is negative, then the data value is to the left of the mean. X has a mean of 60 and a standard deviation of 5. Using the formula, we will next look at our number line and the x value of 70, which corresponds to a z-score of 2. And we will use the formula for z to show that x equals 70, then z equals 2. Our formula is x minus the mean divided by the standard deviation. X is the x value, which is 70, minus the mean, which is 60, divided by the standard deviation, which is 5. 70 minus 60 must be calculated first. 70 minus 60 gives me 10. 10 divided by 5 gives me 2. Notice because 70 is to the right of the mean, we get a positive z-score. And because 70 minus 60 is a positive number, the z-score will be positive. Next, we will use the formula to review that the x value of 45 gives us the corresponding z-score of -3. Use the formula for z to show that if x equals 45, then z equals -3. Z equals x minus the mean divided by the standard deviation. X is the x value of 45 minus the mean, which is 60, divided by the standard deviation of 5. 45 minus 60 is -15. -15 divided by 5 is -3. Remember, it is negative because it is to the left of the mean, and 45 minus 60 is a negative number. So our formula is very useful, and we have proven and shown how it works. But because 45, 50, 55, and so forth are not the only numbers, generally we will have continuous data and have numbers that fall in between the values that fall on exact jumps of our standard deviation. So how should we handle those numbers and find their corresponding z-scores? For example, what if we wanted to know the corresponding z-score for 68? we see that it falls between 65 and 70 and would fall between the corresponding z-scores for those values of 1 and 2 respectively. So what would the corresponding z-score for 68 be? If x equals 68, find the z-value. We would use the formula. Z equals x minus the mean divided by the standard deviation, 68 minus 60 divided by 5, which is 8 divided by 5, which gives us 1.6. And for later use, there is a reason, but we always want to round our z-scores to 2 decimal places. Z-scores are always rounded to 2 decimal places. So this gives us 1.60. Notice it is positive as it falls to the right of the mean. And 1.60 does fall between 1 and 2, just as 68 falls between 65 and 70. Here are some exercises for you to try. You can pause these and try these. Thank you for watching this, and as always, if you need some additional help, please drop by and see me in the Math Learning Lab in MBS 222.